ನಮಸ್ತೆ, ನಾನು ಶ್ವೇತಾ ಪ್ರಿಯದರ್ಶಿನಿ ಫ್ರಮ್ ಡಾನ್ ಬಾಸ್ಕೋ ಇಂಡಿಪೆಂಡೆಂಟ್ PU ಕಾಲೇಜ್. ನಾನಿವತ್ತು ಕೆಮಿಸ್ಟ್ರಿ ಟಾಪಿಕಲ್ಲಿ ಆಲ್ಕೋಹಾಲ್ಸ್, ಫಿನಾಲ್ಸ್ ಆ್ಯಂಡ್ ಈಥರ್ಸ್ ಇದ್ರ ಬಗ್ಗೆ ಮಾತಾಡಬೇಕು ಅಂತ ಇದ್ದೀನಿ. ನಾವು ಆಲ್ಕೋಹಾಲ್ಸ್, ಫಿನಾಲ್ಸ್ ಆ್ಯಂಡ್ ಈಥರ್ಸ್ ಈಸ್ ಒನ್ ಆಫ್ ದಿ ಇಂಪಾರ್ಟೆಂಟ್ ಚಾಪ್ಟರ್ ಫ್ರಮ್ ಯುವರ್ ಸೆಕೆಂಡ್ PU syllabus. Now what are these? What is the functional group present in these? We are going to understand first. Now alcohols, phenols and ethers ಅಂದಿದ ತಕ್ಷಣ ನಮಗೆ ನೆನಪಾಗುವಂಥ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪು OH ಗ್ರೂಪ್. ಆಲ್ಕೋಹಾಲ್ಸ್ ಗ್ರೂಪ್ ಅಂತೂ ಯಾರು ಮಾಡಿರಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ, ದಿ OH ಗ್ರೂಪ್. Now what are alcohols? Alcohols are organic compounds containing the OH group. The hydrogen has been replaced by OH group. Now the general formula for alcohols is ROH. ROH ಅಂತಂದರೆ the R is the aliphatic chain. So ROH compounds are known as alcohols. Example for alcohol is methanol, CH3OH. Now coming to phenols. Phenols are the OH group is attached to the benzene ring, then we call such type of compounds as phenols. The general formula for phenols can be written as AROH. AR ಅಂದರೆ ಏನಿಲ್ಲಿ, ದಿ aromatic ರಿಂಗ್ ಇರುತ್ತಲ್ಲ ಅದನ್ನು AR ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ದಿ OH group is attached to the benzene ring. If it is directly attached to the benzene ring, then only we call it as phenols, or else it is mentioned as alcohols. Now these are two different compounds because they have totally different properties. So if the OH group is attached directly to the benzene ring, it will have a different property compared to the OH group attached to the aliphatic chain. Now coming to ethers. When we talk about ethers, the general formula of ethers can be written as ROR dash. That is, one hydrogen of alcohol will be replaced by one more alkyl group. ಮತ್ತೆ ಇನ್ನೊಂದು ಕಾರ್ಬನ್ಗೆ ಅದು ಲಿಂಕ್ ಆಗಿರುತ್ತೆ, ಅದರಿಂದ ನಾವು ಇದನ್ನು ROR dash ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ದ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಈಥರ್ಸ್ CH3OCH3. That is nothing but dimethyl ether. That is the general name given to CH3OCH3. The IUPAC name is methoxymethane. Now if the OH group is attached to the side chain of the benzene ring, for example benzyl alcohol, then such type of compounds are not considered under phenols, it will be considered under alcohols only. So therefore benzyl alcohol is an example for benzyl alcohol is an example for alcohol, and it is not considered as phenol because it will have the same properties as alcohols and not as phenols. The next we are going to learn is classification of alcohols. So how are the alcohols classified? There are different ways of classification of alcohols. Based on the number of OH group, it is classified as monohydric, dihydric or polyhydric alcohols. So the name itself suggests one OH group, then it is monohydric. If there are two, then it is dihydric, and more than two we considered it as polyhydric alcohols. For example, CH3OH, methanol is an example for the monohydric alcohols. If two OH group are present on the compound, then we call it as dihydric alcohols. If three OH group are present, then we call it as trihydric alcohols and so on. Now coming to based on the OH group attached to which carbon atom, we classify them as primary, secondary or tertiary alcohols. If OH group is attached to primary carbon, that is the carbon containing at least two hydrogen atoms, we call it as primary alcohols. So ee carbon mele eradu hydrogen atom irbeku. Then secondary alcohols, if the OH group is attached to the carbon containing at least one hydrogen atom, then we call it as secondary alcohols. Tertiary alcohols, no hydrogens are present on this carbon atom, it is attached to different groups. Such type of carbon we call it as tertiary carbon, and OH group attached to tertiary carbon we call it as tertiary alcohol. Similarly, it is again classified into different types based on to which carbon atom it is attached to. For example, allylic alcohols. Allylic alcohols, the OH group it attached to the carbon which is linked, which is allylic carbon. Allylic carbon is the carbon which is next to the sp2 hybridized carbon atom. We call such type of alcohols as allylic alcohols. Vinylic alcohols, the OH group is directly attached to the sp2 hybridized carbon atom. Then we call such type of alcohols as vinylic alcohols. Benzylic alcohols, we have already seen this example, benzyl alcohol, wherein the OH group is attached to the side chain of the aromatic ring. We call such type of alcohols as benzylic alcohols. After knowing the classification, see classification we have to understand because examples may be asked in the CET. Now coming to preparation, we should know the different types of preparation which may be again asked in CET. One is from hydrolysis of halides, second is hydration of alkenes, then oxymercuration and deoxymercuration reaction, hydroboration. Grignard reagents can be used for preparation of alcohols depending on whether aldehyde is used, ketone is used or carboxylic acid. We get different types of compounds. The reduction of carbonyl compounds can be used to prepare different types of alcohols. Depending on which type of carbonyl compound is used, different alcohols are obtained. So, these are the different methods of preparation of alcohols. Next, we will understand the properties of alcohols. What all you should stress while studying the properties of alcohols? We should know that there exists a nitrogen bonding between oxygen and hydrogen, and therefore, the boiling point of alcohols are much higher than the corresponding alkanes. So, therefore, this should be remembered, and this, because of this hydrogen bonding, it has specific properties also, which we will understand as we go with the questions. We should also remember that the OH group is acidic in nature, and we should learn some of the tests for differentiating the alcohols to differentiate primary, secondary and tertiary alcohols. So, some tests like Lucas reagent test, oxidation reactions can be used to differentiate the alcohols. Apart from that, for coming to phenols, we should learn the preparation, the acidic character of the phenol. We know that the OH group of phenol is more acidic than alcohols, so it can easily break down, and the phenoxide ion is stabilized by resonance, and therefore it is highly acidic. So, these points should be remembered while answering the CET questions. Now, coming to the OH group, it is ortho and para directing group, and therefore, whenever we try to substitute the other alkyl groups on phenols, we should go for ortho and para positions. Similarly, some of the important reactions you should remember is Reamer-Tiemann reaction, Kolbe's reaction and neutral ferric chloride test for phenols. After this small introduction, let us solve some of the problems which may be asked in competitive exams. The first question, the reaction between an ester and excess of Grignard reagent shall finally result in, Option A, primary alcohols. Option B, secondary alcohols. Option C, tertiary alcohols. Option D, ketone. Now, how do we solve this? We should know the mechanism for the reaction. Now, when we consider an ester, it should be RCOOR dash. Now, we have used Grignard reagent. What is the Grignard reagent? It is nothing but RMgX. We will take up an example and we will try to understand better. Now, when we come to RCOOR dash, say for example CH3 COO CH3 plus CH3 MgBr. Now, when these two reacts, we know that the CH3 will attack the carbon containing double bond O, and therefore, we get the compound CH3 CO MgBr and O CH3, and also the CH3 has attached the carbon and we have CH3 here. Now, when we carry out in the excess of the Grignard reagent, this will shift again. This is a better leaving group and therefore, we get a ketone CH3 C double bond O CH3. Now, this ketone is actually the intermediate compound here because we have used excess of Grignard reagent and therefore, this ketone will further react to form tertiary alcohols. So, one more CH3 group is attached here and therefore, it forms CH3 COH CH3 CH3. So, you can see that when we use excess of Grignard reagent from ketone, it will be converted to tertiary alcohols, and therefore, the product which is being produced in this reaction is tertiary alcohol, which is nothing but option C. So, option C, tertiary alcohol is the correct option. The next question is the structural formula of alcohol that on dehydration would give 2-methyl propene as major product. Option A, CH3 CH2 CH2 CH2OH, CH3 twice CH CH2OH, CH3 CHOH CH2 CH3 and CH3 CHOH CH3. These are the 4 options given. How do we solve this? Now, it is a dehydration reaction. Dehydration reaction, we should remember that hydrogen will be removed from one carbon and OH group from another carbon. So, how do we add that? Take the compound. 2-methyl propene is the product which is obtained. So, 2-methyl propene. Propene contains 3 carbon atoms. 2-methyl propene. So, at the second carbon atom, we should get a CH3 group and we have a double bond there, and therefore, fill it with hydrogens now. We have CH3 C CH3 double bond C CH2. Now, if I add OH to this, look at the options here. When we look at the option, this carbon contains 2 methyl groups. Similarly, option B has 2 methyl groups on the carbon atoms. But we will add the hydrogen and we will try to understand. So, if I add hydrogen to this carbon atom, we have CH3 C CH3 H single bond CH2 OH. So, you can see that the dehydration occurs by removal of HOH to form a double bond, and therefore, this is the starting material. Now, when you look at the options, you can see that the option B is the same as our starting material, and therefore, option B is the correct option. The next question, 2-methyl propene upon hydroboration oxidation gives option A 2-methyl 1-propanol, option B 2-methyl 1-propanol, option C 2-propanol, option D 1-propanol. Now, how do we solve this? Always remember, the hydroboration reaction is mainly for producing primary alcohols. So, whenever we take an alkenes, when we have an alkenes, the hydrogen is added according to Markovnikov's rule, that is the carbon containing more number of hydrogen, and therefore it results in secondary alcohols or tertiary alcohols. But when we carry out hydroboration reaction, it gives primary alcohols basically, and therefore it is against the Markovnikov's rule. Therefore, it is an example for anti-Markovnikov's rule. So, you need not know the reaction here, you can directly say what is the product being formed. Now, look at the options. We have 2-methyl 1-propanol. So, 2-methyl is there already, propene is there, the double bond is there. Now, when 2-methyl 1-propanol is the option, you can see that the alcoholic group has been attached to the first carbon atom. So, it is 1-propanol, whereas the second option propanol, the aldehyde is definitely not obtained from hydroboration reaction, neither 2-propanol or 1-propanol. So, without writing the reaction mechanism, you can guess that it is 2-methyl 1-propanol, and therefore, option A is correct. So, whenever hydroboration reaction takes place, it should be the primary alcohol which should be obtained. The next question is, in Lucas reagent test of alcohols, the appearance of turbidity is due to the formation of option A aldehydes, option B ketones, option C acid chlorides, option D alkyl chlorides. Now, when we come to Lucas reagent test, we have already discussed that Lucas reagent test is used for distinguishing primary alcohols, secondary alcohols and tertiary alcohols. You have already learned this. Primary alcohols, when it reacts with Lucas reagent, then the turbidity does not appear at all. Whereas, when secondary alcohols react with Lucas reagent, it appears only on heating after some time. Whereas, when we come to tertiary alcohols, tertiary alcohols will react with Lucas reagent and turbidity will appear immediately, and because of this different ways of reacting with Lucas reagent, we can use this test for distinguishing alcohols. But what is that happening in Lucas reagent test? That also should be known. Now, when we come to Lucas reagent test, we know that it is used for distinguishing the alcohols. But what is happening in this test should also be known while answering this question. So, when we come to the reaction, the alcohol will react with Lucas reagent. Now, what is the Lucas reagent? It is concentrated HCl and anhydrous zinc chloride. So, the alcohol will react with HCl in the presence of zinc chloride, anhydrous zinc chloride, and the water is released and therefore, it forms RCl. Now, alkyl halides are being formed during the reaction. When it is a tertiary alcohol, it will react very immediately and turbidity will appear immediately, whereas secondary and primary it takes time. So, this shows that the alkyl halides are being formed during the reaction. Now, why is that turbidity? Turbidity is basically because the alkyl halides does not dissolve much in water and therefore, the turbidity appears, whereas the alcohols are more soluble compared to alkyl halides. So, when we come to the turbidity, the reason for it is the formation of alkyl halides. So, option D is the correct option, that is alkyl chlorides. So, option D is the correct answer. The The next question, which of the following will be oxidized by HiO4? The 4 different compounds have been given: RCOCOR, RCOCHOHR, RCHOH, CH2, CHOHR, RCHOH, CHOHR. Now look at these compounds. The periodic acid is a mild oxidizing agent. Now when we consider the mild oxidizing agent, we should know which will get oxidized. 4 different options have been given: A 1, 2 and 3, B 1, 3 and 4, C 1, 2 and 4, D 2, 3 and 4. Now when we consider the compounds, look at the compounds. We have 2 CO groups adjacent to one another in first compound. In the second compound we have COCHOH, which is again adjacent to one another, whereas in third we have CHOH, CH2, CHOH, and in the fourth CHOH, CHOH. Now when you compare all these compounds, there is a gap between OH groups in the third compound, and therefore this is much stable compared to all the other compounds, and hence the third compound will not undergo oxidation. And since the third compound does not undergo oxidation, it is 1, 2 and 4. Look at the option. Which option has 1, 2 and 4? It is the option C. The option C is 1, 2 and 4. So option C is the correct option. So 1, 2 and 4 is the correct compounds. The next question, the end product C of the following sequences: methyl bromide will react with KCN to form A, it will react with, it undergoes hydrolysis to form B, and will react with lithium aluminum hydride to form C. The options are: option A CH3CHO, option B CH3CH2OH, option C CH3CO CH3, option D CH4. Now look at the reaction. What is being done here? We have methyl bromide. Now methyl bromide will react with KCN. Obviously it will form a cyano compound CH3CN. Now this will undergo hydrolysis. When the cyanide undergoes hydrolysis, then it forms CH3COOH. So the compound B is nothing but CH3COOH. Now CH3COOH, when it undergoes reduction, then it forms CH3CH2OH. A primary alcohol is being formed during the reaction. So this carbon will be reduced to form CH2OH, and therefore when we look at the option, alcohol is being prepared. Again, this is one of the methods to prepare primary alcohols. So a primary alcohol is being prepared by this reaction, and therefore option B is the correct option. So the alcohols, they need not ask direct questions. They may include sequence of reactions. You should be able to find out what are the different products which are being formed during the reaction, and hence the option B is the correct option. CH3 CH2 OH, option B. The next we are going to have question on some of the properties of alcohols. Now what is the question? When isopropyl alcohol vapors are passed over heated copper, it gives option A acetone, option B ethyl alcohol, option C methyl alcohol, option D acetaldehyde. Now how do we solve this? When we take isopropyl alcohol, what is isopropyl alcohol? It is nothing but 2-propanol, that is CH3, CH, OH, CH3. Now we know that the copper is a very good dehydrogenating agent, and therefore hydrogen should be removed from the compound. When we remove hydrogen from the compound, then what is the product which we are getting? We get CH3, C double bond O, CH3. It is a very direct question, but we should know that the copper is a very good dehydrogenating agent, and therefore by removal of hydrogen we get CH3CO, CH3. This is nothing but propanone. The common name for propanone is acetone. So the option A is the correct option. Coming to the next question. Identify the starting material in the following reaction. C3H8O undergoes oxidation in the presence of potassium dichromate sulfuric acid to form C3H6O, which on reaction with sodium hydroxide and iodine will form CHI3. Now when you look at the reaction, it looks like some Latin or Greek, but try to analyze in the backwards. How do we do it? Now CHI3 is nothing but the iodoform, CHCl3 is chloroform, similarly CHI3 is iodoform. So this is an iodoform test. Iodoform test is a test exclusively for methyl ketone. So we should have a methyl ketone. So how do we write methyl ketone? We have CH3, C double bond O, then coming to the number of carbon atoms, we have 3 carbon atoms. We have already written methyl ketone group which already contains 2 carbon atoms here, and therefore one more carbon atom should be C, and since it is a ketone, it should be C3, CH3, CO, CH3. Now count the number of carbon atoms. There are 3 carbon atoms, 6 hydrogen atoms and 1 oxygen atom. We have got the same compound. Now by analyzing it backwards, you can easily come to the conclusion what is the starting compound. Now we have a ketone. How can a ketone be formed? From a secondary alcohol. So secondary alcohol, you reduce this ketone. When you reduce this ketone, it will form CH3, COH, CH3. So an alcoholic group is present at the second carbon atom, and it is a secondary alcohol. A secondary alcohol will form a ketone. This ketone will undergo iodoform test to form CHI3. So when you come backwards, it is easy to solve this problem. So what is the compound? We have OH group on the second carbon atom, and we have 3 carbon atoms in the chain, and therefore it is 2-propanol. So 2-propanol is the correct option, and option B is correct, which is 2-propanol.